rationalize a square root. So rationalizing a square root is what we do when we have a square root on the bottom, on the denominator. So we call the bottom the denominator, the top is the numerator. And a division problem is like cutting, like 1/2 of a pie. You're cutting the pie for every whole pie, you're cutting it into two halves. So if you imagine trying to cut something into a number, that number, square root of 2, is at 1.414213562, and this number keeps going forever. So the calculator stops, but it doesn't stop. So how are you supposed to cut a piece of pie into the amount that is like a decimal that never ends? So you can't divide anything by something that never ends. Sort of like you can't divide things by 0. Okay, we later look at that in calculus, and we think of what happens when it starts to get close to 0, the further and further and further close, and we refer to it as infinity. So that gets into the cool concepts. In fact, there's different kinds of infinities. There's cool videos online about that. So sort of like we can't have 0 on the bottom, that's why we can't have a square root of 2 on the bottom. We call those irrational numbers. They're not rational. They're not, almost like saying they're not logical, because it doesn't make logical sense to be able to divide by 0, and the number square root of 2 is irrational in the sense that it's not something you could ever count to. You could never finish counting to this decimal. It would never end, so it's not rational. It doesn't make sense. Sort of like infinity. You could never reach infinity if you were counting, so we would consider it irrational. So we're going to rationalize the square roots, and we're going to take it when the square root's on the bottom. And what we're going to do here is, I'll use letters to kind of represent it, we're going to have something on the bottom. So what we're going to do is pick whatever it is on the bottom, and we're going to multiply the top and the bottom by that number. So the reason we're doing that, okay, this is like taking the number like 2/3. We can multiply the top and the bottom by 3, and it becomes 6/9. So 6/9 is the same as 2/3. We just changed the way it looks, because 3 divided by 3 is really like 1. Anything divided by itself is 1. So we're really multiplying it by 1, but in a way that makes it look a little different. So it looks this way now. So we're not changing the value. We're going to change just the way it looks this way. Okay, and then we can get into practicing multiplying square roots and stuff like that. So we're going to grab the square root of 2. We're taking, here we have a b and a b. We're repeating whatever the number is. So if the number is 7 or square root of 8 or square root of 3, whatever the square root is. And we're going to repeat that. So whenever you multiply anything that's with fractions, we always multiply going straight forward. So we don't crisscross. Cross multiplying is only when there's an equal sign on both sides, like this. Okay, we can cross multiply that way. But when there are multiplication sign in between, we are not allowed to do that. It's not the same thing. So now we have 5 square root of 2 because we're multiplying straight forward. And then square root of 2 times square root of 2, we could really put it under the same umbrella. That's one of the rules. Separate square roots that multiply, we could put them together, which we know we take out the pairs, so it would be normal to, right? The square root of 4 is normal to. So that's one other thing to keep in mind. Any square root times itself becomes the normal value, because it's like saying this is square root of m, this is square root of m on the square, and when we multiply them, the area would be m. So it's working backwards to make a square root, right? If it's m, each side would be square root of m, and this is working in the opposite way. So let's try another one. It doesn't have to be the number 2, so we could take 7 over square root of 3. So we would multiply the top and the bottom by square root of 3. And we get 7 square root of 3 over normal 3. So that's what the basic square root. Sometimes you'll have square roots that are bigger, or that have 2 factors in them, not just 1. So let's take a look at some variations or different types of examples that might be a little more challenging. One One is when you could reduce it at the end. So let's say 10 over square root of 2. So again, to rationalize or get rid of the square root on the bottom, we don't want to put it in a calculator because then we're actually chopping some of the value off. It's really an estimate. So then we do the square root of 2 on top and the bottom. We multiply going forward. 10 times radical 2 is 10 radical 2. Radical 2 times radical 2 is radical 4, which is normal 2. Anytime we multiply two radicals times themselves, the radical sign disappears. So here we know that 10 is 5 times 2, so we could reduce. So 5 radical 2. Whole numbers can reduce with whole numbers, and square roots that are the same square root can reduce with the same square root. So let's try another one. So there's sometimes that situation where we have to reduce, sometimes where the square root let's make it with the square root that ends up having a whole number on top as well as on the bottom. So we're not concerned about the square root on top, we're just trying to rationalize and get rid of the denominator. So again, we repeat the same number and we multiply going forward. And so when we multiply, that's another lesson that we did about square roots. You could always look up lessons on multiplying square roots, but we multiply whole numbers with whole numbers. There's an invisible 1 here. 2 times 1 is 2. And then square root of 3 times square root of 5, we can put it in the same umbrella. That was one of the rules. So we know it's 2 square root of 15. The rules of multiplying square roots is we could take two separate ones and we could put them under the same umbrella. So square root of 3 times square root of 5, we can put them in the same umbrella. And then on the bottom we had normal 5. And there's nothing we could reduce. The 3 and the 5, there's no pairs to take out, so we would just leave it like this with the square root of 15 on top. And then let's try one more example. So this one's going to be a little bit different because at the end we're going to be able to take something out of the square root. So again, the first thing we need to do to work with this and simplify it is we need to rationalize the denominator. We multiply straightforward. Whole number with whole number. 3 times 1 is 3. Remember, like things like x and y and a square root have an invisible 1. There's really one of them. And then square root of 3 times square root of 6 is square root of 18. Square root of 6 times square root of 6 is normal 6. So there's two things we can do here. 3 divided by 6 we can reduce to 1/2, right? 2 times 3 makes 6. The 3 reduces. But the other thing we could do is we can reduce 18. The factors of 18 are 2 times 3 times 3. So we learned that when we take a square root out, we take the pair and take it outside of the square root sign. We have a 2 left over and a 2 on the bottom. So we rationalized the denominator on this one, but then at the end, we both reduced the 3 and the 6, as well as at the very end, we simplified the square root and took out the pair. So that's the review of rationalizing the denominator. I hope that helps some of you.